Hey everyone, hope you had a nice weekend. Today we're taking a jump from the two-dimensional geometry, the flat, to three-dimensional geometry, our expanded figures that we can see that take up space, take up volume. So down here on our Do Now, we're going to name the space figures. Obviously, this is just a flat two-dimensional representation of what we would see in 3D in real life. So number one, the Pepsi, our soda can, right? That would be our cylinder. Boom. The soccer ball we would call our sphere. See if that stays there. Nope, not going to cooperate. And then number three, the Great Pyramid of Giza. And we see the Sphinx there, really looking at that Great Pyramid. Yes, it's a pyramid, but does anybody know what specific type of pyramid it is? And we name pyramids based on their bottom shape. Okay. This is actually what we would call a square pyramid or a square-based pyramid. And it looks like that. Just want to go over a touch of vocabulary from our two-dimensional vocabulary on page 5, having to do with our polygons. Just to review a few shape names and number of sides. A pentagon has 5 sides. A hexagon has 6 sides. A septagon or heptagon, either name's acceptable, has 7 sides. We won't see that one a lot. And then an octagon has 8 sides. Not as popular, the nonagon has 9 sides and the decagon has 10 sides. But really, I think the key ones to know there, pentagon 5 sides, hexagon 6 sides, octagon 8 sides. Let's go over a little vocabulary for our three-dimensional figures on page 30. Polyhedron, a three-dimensional shape that has polygons as faces. That's basically the three-dimensional word for polygons. An edge is where two faces of a polyhedron meet. So sort of these, so if I'm looking here at a rectangular prism, these are our faces, these rectangles. Where they meet, that's an edge. Okay, we also see it on our pyramids. The faces are triangles. Where they meet here is our edge. Okay. The base is the flat two-dimensional surface. If it's a prism, it has 2 of them. So a rectangular prism has 2. These 2 rectangles here, yes, they are actually squares. Or our square-based prism has 1 base here, this square. Okay. Couple of other things we note here. We have vertices on our polyhedron where all of our edges meet. Vertex is singular, vertices is plural. Pyramids come to 1 singular vertex up top. Okay. And then we want to notice, right, we've got our non-polyhedrons. That would be our cylinder with our 2 circular bases, and then our curved area here. Our cone, right, ice cream cone, traffic cone, party hat, and then finally our sphere. Just to review a couple of vocabulary words we just went over a little informally, I wanted to reinforce that a face is that flat surface of a three-dimensional figure. Could be a rectangle, could be a triangle, okay? An edge is where the 2 faces meet, so that here is in yellow. And that a vertex is where 2 or 3 edges meet. So that's shown here with this green circle. All right, let's go over some key differences between prisms and pyramids. So I've got an example of a prism here, a triangular prism. I drew a rectangular prism. And then I've got an example of a square-based pyramid, and I drew one also. So some key differences is that prisms, they have 2 parallel, congruent bases. Okay, so here this is a triangular prism, so they have 2 triangle bases that are on opposite sides that are parallel and congruent, so equal. And then our pyramid just has 1 base. Okay, square pyramid, 1 square base. You could have a triangular pyramid, triangle base, hexagonal pyramid, pentagonal pyramid, and so on. Okay? On our prism, the faces, okay, so those non-base sides are always rectangles. Okay, so in a prism, you have rectangular faces. On a pyramid, you have triangular faces. Okay. Now let's talk a little bit about the edges of each of these shapes. So remember, edges are where your faces and your bases meet. On a triangular prism, if I count it out, I've got 1, 2, 3 on the first base, 4, 5, 6 on the second base, and then another 3 edges connecting those 2 bases. Okay, so if you look at that, it's the number of edges of the base times 3. Okay, so if we jot that down, and that's just kind of like a fact, you can visualize it, you can use it as a fact, not something I'm going to ask you specifically, what's the relationship of the edges on a prism? Okay, so if we look at that, number of edges is 3 times that number of sides of the base. Okay. On our pyramid, if we look at our square pyramid, okay, the base has 1, 2, 3, 4 edges, and then another 1, 2, 3, 4 connecting to that top point, that top vertex. So a total of 8 edges. On our pyramid, number of edges is 2 times the number of the sides of the base. Okay. We can also look at a relationship of the number of vertices, so those sort of corner points. Triangular prism has 3 on one base, 3 on the other. So we can think of that as 2 times the number of sides. So number of vertices, okay, is 2 times the number of sides of the base. Okay. On our pyramid, it'll be the number of sides of the base plus 1, plus that top guy. Okay. So on the pyramid, number of vertices is 1 plus number of sides of the base. Okay. You might ask, wow, prisms and pyramids have a lot of differences. So you might say, do they have anything in common? They do. What they have in common is that they are named by their base. So they are both named by the base shape. Now we're taking a look at page 31 in our booklet, which is sort of going to be our led through classwork, I guess. At part 1, we're asked to give the corresponding number for each of the following space figures. And now this was designed to do in class, and what we're going to do, we're going to have those wood blocks you saw me with, and each one had a number on them, and you're going to pick them up and turn them around and name them. Obviously, we can't do that right now. So what I'm going to do is I'm going to give you a picture with all of our images named, and I want you to take a look at that and answer part 1. So go ahead, pause the video, and then we will reveal the answer. So go ahead, pause. There is our solution. For the rest of the page, we're going to kind of break it down into parts, and you're going to answer the questions on the Edpuzzle, and then I will reveal the answers. So part 2, complete the following problems. Name each space figure. Boom. Questions. Answers. Here I can see it is a pyramid, so I'm just looking for the base now. I see the base. To me, it looks like it has 5 sides, so I'm going to say that that is a pentagonal pyramid. Some people say pentagonal. I say pentagonal. Number 2, some people, students in the past, have said it looks like a wedge of cheese, and there's been debate, pyramid or prism. What I see is 2 parallel congruent triangular bases and rectangular faces. So this is in fact a triangular prism. I know it's not a pyramid because it doesn't come to that point on top. Number 3, I think we can see pretty clearly that that is our cone. Okay. On to numbers 4 through 9. Let's just do numbers 4, 5, and 6 first. So you're going to fill in the blank. Go ahead, do your questions. Answers. Each lateral face of a rectangular pyramid is it's a pyramid. Don't care what the base is, it's a pyramid. That means our faces are triangles. Number 5, each lateral face of a trapezoidal prism, every face of a prism is a rectangle. Okay. And then number 6, the base of a hexagonal prism is a hexagon, right? We're always naming by its base. Let's go on to numbers 7, 8, and 9 now. Go ahead, do your problems. Answers. An octagonal prism. So octagonal prism, I have an example right here. How many lateral faces does it have? That's those rectangles. If an octagon has 8 sides, it's going to have 8 lateral faces. It's a prism, so it has 2 bases that are, and really here I would expect 2 answers, but obviously I only gave you 1 option in the multiple choice that are octagons. Okay. In years past, some people have said congruent also, that are equal. I think that's a good descriptor there. Okay. Number 8, a rectangular prism. So let's take a look at our rectangular prism. I have it here. We want to visualize. Has how many vertices? So that's where we're talking in the notes. The number of vertices is going to be 2 times the number of sides of the base. Rectangle has 4 sides times 2. It's going to have 8 vertices. Number of edges, that's where we were doing times 3. So 4 times 3 is 12. And how many lateral faces? That's 4. Okay. The last one, number 9, that's where we can get a little interesting with things. And again, I only gave you 1 option on the multiple choice. A space figure with 6 congruent faces. I would say our best answer there is a hexagonal prism or hexagonal pyramid. Okay, when that base has 6 sides. Some people would argue that the cube could be considered that. I would argue not so much because we're talking specifically faces, and yes, the base of a cube is congruent to the faces. I think hexagonal pyramid or prism is a stronger answer, but again, up to you there. Okay? All right, number 3, identify each of the following space figures based on the given nets. The nets is sort of that unfolded object, as if we had done it with paper, which is an activity we would have done down below in class, but you know, not so much today. But take a second, finish part 3, write in your answers, and there we go. Okay, answers. So here I see those 4 rectangular faces on the end there. I'm going to say that that is a rectangular prism. Number 11 would be a cylinder. Tomorrow we'll talk more about the net of the cylinder. Number 12 would be a cube. 13 would be a square pyramid. And 14, the cone. Okay, so today really for classwork, this is it, page 31. So just take a snapshot of your notes that you filled out here, post it on Padlet, and tomorrow we'll talk more about surface area, sort of the outside of these 3-dimensional figures. Have a great day, guys. Little math joke for you today. Why was the math book so sad? Because it had so many problems. Ha ha ha.